Hey, what's going on, guys? Xiangqi here. So after the successful passing of the perf test, we're now going straight ahead to having the very first proof of concept complete product, and I'm really so tempted to just write the code without making the videos, because it's really tempted to see how the end result would look like, because that's so probably always like so if you didn't yet done something similar before. But yeah, well, obviously the international Western chess is also kind of something similar. But this night I was playing around with rendering the Xiangqi board within the browser, and that was absolutely amazing experience. But anyway, so probably I would have been tighten the content even more. And when it comes to, so today we're gonna be working on hashing, everything that regards to generating the hash key, and not sure if the incremental updates as well or not. We'll see this just during this video. I don't know yet. And then when it comes to search, I will basically take the search from Wukong.js, because this is just the regular alphabet search with some sort of a basic optimizations. And regarding the evaluation, I also need to grab p-square tables from somewhere, because to be honest, I have no idea how they should be, how they should look like within CNC engines. It's a little bit unclear to me at the moment, and we'll see how it would be playing. And then just grab the GUI from Wukong.js as well, and just alter a couple of functions to... Okay, hold on a sec. Okay, sorry guys, my cats are fighting down there. Okay, so and then the GUI is literally the same that we have at Wukong.js at the moment. Just the difference is we just need a CNC board instead of chessboard. So different piece pictures, board size would be different, and the background texture to make pieces fit in these lines, not match the square, but just to be in the center of crossing lines. So that's the reason. So that's kind of it basically. And yeah, the code is very self-explanatory. So for me personally, like ending up a mode generator literally means the end up of the entire tutorial series, because for me personally, this mode generator is the most essential core part of whatever engine, and searches and evaluation, they are pretty general, so they're literally more or less the same regardless of chess variant at all. So anyway, without further ado, now we will go for implementing our Zobrist hashing, and let's actually start. So I would be referencing my Wukong.js code here. So we'll start with the pseudo-random number generator. I just grabbed this. This is a very simple algorithm that is called XOR 32, XOR shift 32 bits, 32-bit XOR shift from Wikipedia. Nothing interesting. So the idea is to generate same random numbers regardless of operating environment. So I'm using the fixed random seed here, and then just generating these numbers. This would be called only once to generate random numbers for pieces, to hash pieces. And eventually we will obtain a 32-bit number that would be representing, that would be serving as the unique position identifier. 32 bits should be literally enough for detecting repetitions, but also we would be using that for a hash table, even though that would probably be leading to some collisions, but I think that would be just fine for start, because it's not that super fast engine. So if it works in regular chess, I hope this should be working in CNC as well. So let's go, and we'll no, this one is not about to be different. Nope, this one would be exactly the same. So board variables, board methods. Yeah, so here after the board methods, I would like to paste my pseudo-random number generator. nothing really to demonstrate here. It's just okay, just generates the pseudo random 32-bit number, nothing much really. Okay. Okay, so if we just call this random, this would give us just a random number like this, nothing even to demonstrate here. And this is just a random number, nothing much. Again, like for the purpose of having the same random numbers all the time. Okay, and then the Zobrist keys, absolutely essential routines. So just copy. Well, actually I had them before the board methods even. So maybe this is a good idea, maybe not. Yeah, maybe just put them after. Okay. So Zobrist keys here. Save. Make sure indentations match. Okay. Now this should be altered a little bit to make it to work properly. So the size of array, so we don't need castling keys because there is no castling in CNC. We only need the side keys and the piece keys. So the size of this array was taken like the number of pieces multiplied by the number of squares. So the number of pieces is in CNC is different. It's not 13, it should be 14. Actually 15 with this empty one. So yeah, 0, 1, 2, 3, 4, 5, 6. No, I mean, like here we have 15 pieces, so we would be having the array, so we don't need to hash the offboard, just these pieces. So yeah, we had 13, now we will have 14. But hold on a sec. Actually, just hold on a sec. I'm sorry guys, just I don't remember, just need to make sure that everything works properly. So I just need to count pieces exactly. So there should be, yeah, one more than the number of pieces. Yeah, so where are the pieces? That's a little bit strange. Just hold on a sec. Const let's say pawn. Yeah, here they are. Here they are. Okay, so 6, right? 1, 2, 3, 4, 5, 6, and 6, 12. So one more than 12, so 13. And here in CNC we have 7 and 7, 14. So 1, 2, 3, 4. Yeah, so 14. And so we need one more, 15, to make sure that black hen would get hashed as well. So 15 multiplied by 15 multiplied by, okay, let me just really, or let it just stay where it is. Okay, so we need 15 multiplied by the number of board squares. So we have the array of 11 multiplied by 14, so I need to calculate that. 154. Yeah, 154. Okay, so now we are initializing our random keys. So here for pieces we're using this. Okay, so literally the length of the piece keys. I can actually, yeah, I can use, I guess I can use the piece keys dot length here. for castling, so we're not gonna be initializing castling. So we're just getting 154 multiplied by 15 random numbers, so that's just a plain array, one-dimensional array. Also side key is also a random number. Okay, so already I want to have a look at this sort of a thing, because yeah, so init random keys should be within the init all, if I'm not mistaken. So init random keys, yeah, so this should be within the init all. Copy, and also I was generating hash key yeah, at init all. Okay, so go into our init all, and the very first thing is init random keys, and the piece keys and side keys. So here, instead of this hashing, I just want to say console.log, and I want to log, let's say, side key, and console.log piece keys. So just the random number for a while. So let's update. Okay, so we got this random number for this side, and this random numbers for, so 2310, yeah, and this random numbers to hash pieces. Okay, perfect. So absolutely fantastic. It's okay they are negative. In order to get done with the hash table, we would just be would be bitwise the hash key with the 32 bits, and that would be getting rid of the 32nd bit that represents whether the number is positive or negative, and that's the way to go basically. Okay, so let's just drop back to the initial position. Okay, and now generate hash move. So Control F, generate hash move. Okay, so final key, something the variable would be XORing the variable that we would be XORing with piece key. So this is the XOR operator. I've been explaining how this works in the previous, so now we just go for implementation. Okay, so hash board position. So here let's use the variable board.length. So we need this 154 literally. Also, yeah, if square is not equal to offboard. So okay, just where is my print board? Just want to make sure the condition matches print board. Okay, it's not. This is also a possible way, but okay, how did I do this within set board fen? This is interesting. I've been using this condition. Well, another option would be, oh, hold on a sec. No, not really. This is the reset board, not set board fen, but here we got the same. Yeah, I'm looking at this code and I have no idea why I was doing this like so. Why didn't I say board indexed by the square is not equal to offboard? But this is also on the card, so yeah, let's actually go for this. So to make it at least similar through the code, generate hash key. So I just want to make sure that just print the coordinates again. So coordinates and the square. Save, and now go into debug, and I want to run generate hash key. Let's have a look. So the squares, white is not, okay, that's just didn't fixed yet. A0, B0 to I0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, seems to be correct. Okay, so generate, oh, what have I done? Generate hash key. Okay, so in this case we want to, so why do I use in the variable here? Let piece equals to word square. So we initializing the piece here, and in the case if the piece is not empty, so we're not hashing empty squares, only pieces. In that case, we are XORing the final key with piece keys, and now piece multiplied by the board length. Board length. Okay, square, and then hash board variables. So side is about to be hashed only if side is equal to red. Okay. In peasant is not an option. Hold on a sec. Hold on a sec, guys. I'm just wondering, why did I do? Oh yeah, that's all fine. Yeah, and we don't need the. I was just thinking regarding the implementation of Zobrist hashing within OpenJS. Doesn't matter really. So we don't have neither castling nor in peasant capture in CNC, fortunately. So only hashing the pieces, right? And hashing the board state variables, and this is all we can do, right? This should be, seems like. Okay, I'm just checking things. Final key XOR side key if side is equal to red. Well, this should be working. So let's update and Control F. And let's try to log this. Console.log, generate hash key, save, update. So here is the hash key for restarting position. Okay. So now let's try to play around with the site, let's say. So we say site XOR equals 1, and then log again, and then again site XOR equals 1, and then again this should be changed back and forth. Yeah, so change to different value and then change back after the second XORing. So this is okay. Yeah, this is fine. Okay, this is okay. So now the hash key variable. So let's go to the board representation, board variables here. So we will also have, let's put it here, hash key. So this is the unique position, let's say almost unique to be exact, almost unique position identifier, and identifier. Did I spell this correctly? Hope so. So hash key equals to 0. Okay. Now as far as, yes, I'm not going to be initializing this with an all init, because in OpenJS there was some other reason for doing this, and here hash key should be initialized. It should get resetted within the reset board. So we need to say hash key is equal to 0. Okay, and within the set board FEN, within the set board FEN, after we've done all of the stuff, right, we want to initially generate hash key. So we say hash key equals to generate hash key. Okay, and also I want to print the hash key within the print board. So well, let's say here I would say board string plus equals hash key and plus it's probably a little bit, well, doesn't matter, hash key. Save. So let's have a look. Okay, we got this. Okay, I want also the new line character. Okay, let's probably make it, well, no, yeah, let's make it 1 square to the left. Yeah, I think this should be, I don't really like the layout, but yeah, let's just leave it as is. Okay, so we got the hash key. Okay, and now we only need to update that. So okay guys, just want to make sure I didn't miss anything. So okay, I'm printing this, resetting within the reset board, initializing at parse FEN. Okay, so resetting at the reset, oh, so okay, this one is not needed. I'm doing this within the parse FEN. Okay, so definition, generate, reset, done. Okay, so yeah, this is the incremental updates. We didn't yet implement that. Okay, hash key. So all these are incremental updates. And then we also, okay, so this is another thing. So starting, yeah, with this incremental updates. Okay, so now we would be debugging this incremental updating of the hash key. Well, we don't yet have the making the null move, but that's just fine. That is just fine. Okay, yeah, let's probably stop here, and starting from the next video we would be incrementally updating our hash keys. So I think that's the way to go. Okay guys, so this is it from my side. Thanks for watching. Until the next time, and take care.